For centuries, tanks were considered the undisputed masters of land operations, with their thick armor and massive barrels. But a recent global conflict was about to shatter this assumption. On the enemy lines, there was no massive tracked monster, nor an invisible stealth fighter. What left whole armies utterly helpless was a few rockets mounted on an ordinary transport truck, wiping out critical points and ammo depots behind enemy lines overnight. At first glance, looking no different than a standard logistics truck, this system cast aside heavy steel armor to be designed entirely around lightness and speed. Defying the weeks-long transport times of heavy-tracked giants, this truck could be airlifted to any point on the globe within hours, strike the enemy, and vanish into thin air. But this brilliant move of military engineering concealed a massive, multi-billion-dollar vulnerability. Because what made this vehicle lethal wasn't the explosives it carried, but the coordinate data it received from invisible satellites in the sky. But what if the enemy jams these signals, turning these billion-dollar missiles into blind fireworks? This very question kicked off the greatest cat-and-mouse game in modern defense history. Throughout history, the greatest mistake of military engineers has often been the belief that bigger and heavier is always better. During the Cold War era, the United States designed massive tracked monsters to keep the enemy under a crushing bombardment. These vehicles possessed immense destructive power. But when the Gulf War broke out, they faced a harsh reality. Transporting these 25-ton steel walls across the ocean to crisis zones was an absolute logistical nightmare. America's standard C-130 transport planes couldn't carry these vehicles, and it took weeks for giant ships to dock at ports. In light of this, the Pentagon pursued one critical question: can we build a system that fits into the belly of a cargo plane and enters the fight within minutes without sacrificing firepower? The solution actually seemed simple. Scrap the heavy-tracked chassis entirely and mount the system onto the back of a standard six-wheeled military truck. That is how the M142 Himars concept was born. Now, a cargo's plane could easily carry this truck, and just 15 minutes after the wheels touched the runway, the vehicle was ready to fire. But in military engineering, no advantage comes without a cost. When you strip away heavy armor and tracks, the laws of physics hand you a brutal bill. How would this lightweight truck chassis withstand the pressure of massive rockets generating tons of recoil force? The initial tests ended in a complete fiasco. The scorching gases, reaching thousands of degrees, and the shockwave blasting from the massive rocket tubes turned the standard truck cabin into an absolute oven, melting the electronic systems inside. What's more, the immense torque at the moment of launch left permanent damage on the truck's chassis, causing the very next shot to completely miss the target. The engineers hit a dead end. Engineering brilliance stepped in right here. Instead of making the entire chassis heavy, they developed special deflectors to vent the gas and pressure to the sides of the vehicle during launch, along with lightweight but flexible titanium alloy supports. The cabin was equipped with a specialized sealing and positive pressure system, resembling an astronaut capsule. In this way, the rocket's toxic gases were blocked from ever reaching the crew. Himars was now light, fast, and flawlessly ready on paper. But the real test wouldn't be in theory. It would be faced under the brutal conditions of actual warfare. Deployed to the Ukrainian theater, the Himars turned into instant legends during the first few months. The massive artillery logistics, the Russian army's greatest strength, was systematically destroyed by precision strikes from 80 kilometers behind the front lines. Instead of blindly carpet bombing an entire area like conventional rocket launchers, Himars missiles could fly directly through the windows of a building. The Pentagon and global media were quick to declare this system the absolute victor of modern warfare. Thanks to its shoot and scoot capability, the Russian army couldn't destroy even a single Himars vehicle for months. As if that weren't enough, the Ukrainian army built full-scale decoy Himars made entirely of wood to deceive Russian reconnaissance drones. Russia was forced to develop a new strategy and countermeasures against this situation. While Ukraine's offensive momentum remained strong, this success story would soon hit a wall. Starting from the middle of 2023, strange reports began trickling in from the front lines. The million-dollar GMLRS rockets, which hit their targets with centimeter-level precision at the beginning of the war, were suddenly falling into empty fields, missing their marks by hundreds of meters. The Russian army had deployed a massive electronic jamming umbrella along the front lines. Himars' heavy reliance on GPS satellite signals, its greatest strength, turned into its ultimate weakness. The global defense industry was in shock. Was a multi-billion-dollar high-tech system being rendered completely ineffective against jammers costing just a few $100,000? This war of digital blindness triggered a massive software and engineering race behind the scenes. American engineers urgently updated the systems to prevent the rockets from relying solely on GPS. Advanced INS software integrated directly into the rockets was deployed. It calculated positioning using highly precise internal gyroscopes, completely independent of any external signals. As the enemy shifted their jamming frequencies, Himars rockets began using dynamic algorithms that changed frequencies thousands of times per second. The story of Himars shows us that modern warfare is no longer just about dropping bigger bombs or producing thicker armor. This vehicle, thanks to its logistical flexibility and speed, radically changed military tactics. Yet at the same time, it proved to the entire world just how dependent modern high-tech weapons are on fragile signal lines. At the end of the day, the winner won't be the steel plates on the vehicle, but the side that best manages the invisible signals and software guiding that steel. Because on the battlefields of the future, absolute victory will belong not to those with the heaviest armor, but to those who move the fastest, lock onto the right signal, and vanish into the darkness without leaving a trace.